Hi, this is a collection of videos covering different concepts of Kubernetes. For topics other than what is covered in this video, please check out the channel, and if you are looking for any new topic, just add a comment. Thank you and happy learning.
Hello, in this video, we're going to see how to create a pod. So let's look at the manifest that we are going to use for this exercise. So we're going to create a pod in the default namespace, and we are going to give it the name po-kube train. The pod is going to have a container inside it, which will carry the Apache image. So this pod has only got one container in it. But we can also have more than one container, but most of the times, the best practice is to use one container within the pod unless required. As we know, pod is the basic building block in Kubernetes. It is the fundamental object in Kubernetes, and the pod would come with, get attached with things such as containers, volumes, and so on. But let's create a basic pod here, a basic Apache pod. kubectl create -f the file name. So the pod should get created now. So just getting back to the manifest again, we see that there is an API version v1 and the kind pod. So in Kubernetes, any object has a kind and an API version. And in Kubernetes, we have got short forms for most of the objects. For example, deploy for deployment, RS, replica set, and so on. So if you give something like explain is the verb, and PO is the short form for pods, we would know the API version and the kind for it, the complete details of it, but we can grep just the initial details by using the head keyword. So we see the kind is going to be capital P pod, this is case sensitive, all the keywords are case sensitive, and we can use the v1 version for pod. Now we know that the pod has got created. Let's check its status by using the get command followed by pods or PO short form. The pod is running. We can get into the container which is specified in the pod. So we can use the kubectl exec command followed by -it, followed by the pod name, followed by bash. This will take us to the bash prompt of it. So this is nothing but an Apache container. So we could use the curl command to curl the local host inside the container. But by default, this container may not have the curl command. So we need to install curl by using apt update. And after that, we can give apt install curl -y. So curl is now installed. Let's try the same curl command again, curl localhost. So it says it works. So this is the HTML code, and this means that the Apache code is now working. Let's try to create a sample file here. So let's try to put something inside this echo test text. So this is just a sample text which we are going to put inside a new file called as test.txt, just a file name. It's created now. This file is existing inside this container. We have got this file, we saw the contents of this file. Now we are going to kill this container. Kill one. One is the process ID of the container itself. So we are going to kill this container. We are out of the container. Let's check if the pod is still existing. Yes, it is existing. Let's try to get into the pod again, like we did before. We are in the container right now, and let's see the contents of it. So we don't see the file anymore, which means that this container is different. Just by looking at the prompt, we may not be knowing if this is a new container or not. That's why I had to create a sample file just to show you that that container is different and this container is different. So we see a new container, but the pod is still existing. The container has got restarted by the pod. So the pod is on top of container. You kill the container, the pod is going to recreate it for you. So that was an illustration on how the container got restarted by the pod. Now let's see a few more details about this pod by using the describe command. describe PO for pods, followed by the name of the pod, which is PO-kube train. So these are the events about the pod. We see more details about the secrets that it uses, what image it is pulling, and so on. We could also use one more handy command called get pods, the pod name, followed by output YAML. -o for output format, and YAML is the YAML format. We see the complete description of it. Even though we gave only a small amount of YAML manifest, we see a big file here, which is the complete manifest of the running pod. We could also give something like -o wide, which would give a tabular format of the pod, and it would also tell on which node this pod is currently running, and the IP of the pod too. So this was about pods. We saw how to create a pod. We saw how to get into the container, which is in the pod. We tried to kill the container. We saw the pod was restarting it. Then we looked at a few handy commands on how to list more details about the pod. And we are finally going to delete the pod. Delete pod, all. All will delete all the pods, or we can also explicitly specify the pod name instead of -all. And one thing to remember is that the kubectl commands are going to be similar for most of the objects. The first term is going to be kubectl followed by the verb. The verb is something like delete, get, and so on, or describe, and so on, followed by the object type. In this case, it is PO, which is a short form for pods. Like this, the command format is going to be similar for most of the objects in Kubernetes. Hope this video was helpful, and we thank you for watching. Hello, in this video, we're going to see about the role of Docker in Kubernetes. So we have a running cluster on the Google Kubernetes engine. We've got 3 worker nodes, and all of them will have a container runtime, which is Docker in this case. Docker is a common runtime, which is installed on all of these worker instances. So a prerequisite for this video is to have some understanding of Kubernetes pods and Docker containers. Let's go ahead and create a pod from a sample manifest to illustrate this in a practical way. So we have got this manifest using which we're going to create an Apache pod, inside which there's going to be an Apache container. Let's go ahead and create this. But before this, let's delete all the pods if there is any on the default namespace. I'm just going to delete it now. And after that, I'd go ahead and create it by using the create command. Create -f and the file name. So the pod should now get created. To see where this pod is launched right now, you could use the white flag. And we see that it is on one of the instances, one of the worker nodes, which is this. I just copied it. And if I have to see the list of Docker containers in that node, specifically in that worker instance, I could use the gcloud compute SSH command. So I'm just going to pass a command to the instance using the echo command. So I'd say Docker container ls for listing it. And I'd like to grep the container which we launched just now, which is Apache. The name of the pod is pod hyphen, yeah, it's just Apache. So I'm just going to grep for this word. And I'm going to pass this entire thing to this instance using the gcloud compute SSH command. And I'll paste the instance's name. So this command is actually going to be executed in the remote instance. Okay, it's getting executed now. Okay, now we get some output down here. So if you see this, there is the Apache container, which is HTTPD, and there is one other container, which is this, which is launched as the pod sandbox. So if you see the word, it says it's pod underscore Apache, but here it is just Apache. So this is the real container. The first one is the container for the real application, the Apache application, whereas the next container is the pod sandbox, which is kind of a high-level object about the app container. So if at all we have to delete this one, so if we go ahead and delete this container, we can remove it using Docker. So I'm just going to use a similar command, but this time I'd stop the container using the stop command, and I would paste the container ID. Okay, This is the container ID. I'm just going to stop it gracefully. And after that, I would remove it. After stopping, I can actually remove it using the rm command. So instead of stop, I'm just going to say rm, which would take the container off. The container is taken off, is removed from the instance using Docker. Even though if you see the status of the pod right now, so you remove the container, you're just going to see the pod status. It should still be running. So it is running, but the restart count has increased by 1 because the pod has understood there is a container restart. I mean, the container got killed and it is restarting it automatically. So this is how interaction happens between Kubernetes and Docker. Kubernetes is actually automatically restarting the underlying Docker container. And this time, if we have to kind of use the same Docker command and see if there is any new container that exists, we should see a new one. The old container got deleted, but you would see a new container for the HTTPD image with a different container ID. So you have got a different container ID here. Fine. Now let's go ahead and delete this container. Instead of the application container, we're going to delete the pod sandbox container, and let's see what's going to happen. So we are going to issue the same Docker container stop command, but we would replace the container ID. So we would stop the container first to gracefully stop it, and we copy this one, the container ID of the pod sandbox. And I'll take the extra spaces. I'm stopping it now. And after stopping, I would remove it. So gracefully stop it and then remove it. So take stop off and put rm instead. This is going to remove it. The pod sandbox is removed right now. So this is like an overlying, it's like a high level object to the app container. And if you have to see the status of the pod again, you would see that it is still running, and the restart, again, the counter has increased by one other number. And this time, if you have to again go to the instance, the worker instance, and see the list of containers again, you would see again a new container ID there. So grep Apache, which is the name of the pod that we gave. And if you grep it, you would see 2 containers again, but the IDs have got replaced. So you're seeing 2 different IDs for both the containers. So what it means is that if you kill the app container, it is going to be restarted. It is not going to affect the pod sandbox. But if you kill the pod sandbox, it is going to affect both of them, because the app container is actually kind of linked inside the pod sandbox. So killing the pod sandbox would actually kill both of them, and both of them would be restarted. But killing the app container is only going to reset that app container. In either case, the pod will still be running because the underlying containers are going to be restarted by Kubernetes. So this is how Kubernetes monitors the Docker containers and recreates for them. So if you have to individually create a container, you wouldn't have the intelligence of actually recreating it. That is why you need objects which are defined by Kubernetes to monitor the underlying Docker containers, auto heal them, and auto recover them. Now let's go ahead and do the cleanup. So delete pod -- all would actually delete all of the pods from the default namespace, because we are not specifying the namespace here. It would go ahead and pick the pods, all the pods in the default namespace. Anyway, we have got only 1 in the default namespace right now. Okay, so it's cleaned up. There's no more pods. Fine. So we came to the end of this exercise. Hope this module was helpful, and we thank you for watching it. Hello. We'll see how to create a replica set object in this video. The prerequisite would be to have some knowledge about pods, how to create them. So let's look at the manifest of our replica set object here. So app/v1 is going to be the API version for this. We have given this a name, rs-kube-train, and replicas is something very important in the manifest. So by specifying the number in the replica section, we are going to say how many pod replicas we want the replica set to launch for us. So in this case, we are going to launch 4 pods, and we can change this number. If we don't mention the replicas here, it is going to take 1 by default. And then we have got the selector section, wherein we would pick labels from the pod. So whichever pod has got this label will be part of this replica set. So this section has to match with the labels section of the pod. So this and this should match. And template is nothing but the section wherein we give all the details about the pod. So under the metadata, we don't have to give the name because the name is going to be assigned by the replica set itself. And then we have got the pod spec wherein we say we need the nginx container. We're going to use the nginx container to keep it simple. But yes, we can use any container image that we want. We can take it from the Docker Hub. By default, this cluster is going to use Docker Hub for its images. And finally, let's go ahead and create the replica set by using the create command. The replica set is created. We can check its status. RS is the short form for replica set. So 4 is ready now. Let's see all the pods. Get pods. We see all the 4 pods are running. We could also use -o wide to see the nodes on which these pods are running. Delete pods -- all is going to delete all the pods for us from the default namespace. So all the pods are getting deleted. Now let's go ahead and see kubectl get pods, and we'll use the watch flag. PO is the short form for pods. We see a new list is running now. We have got 4 new pods with different names, and all of them are running. We could also change the number of replicas inside the replica manifest. 6, Control X, Y. Let's try to apply it now because we only changed the replica section. We didn't have to create it again. We just say apply to modify the existing replica set, and we call the name of the file here. Okay, so it's configured now. Let's check the status of the replica set. So 6 is ready. Get RS, get pods. We've got 6 pods running. Call its name rs-cube train to delete it. The replica set is deleted. The pods will also get deleted. We could use the -watch flag, double -watch flag to see the live status of the pods. So there seems to be no pod, I think. Maybe they got deleted already. Yeah, no resources found. All the pods are deleted quickly. So this is how a replica set would work. So in this video, we had seen how to create a replica set using a manifest, a YAML manifest. We tried to increase the number of replicas, and we tried to delete the pods, and we saw how the replica set is recreating them. And finally, we did a cleanup by deleting the replica set, which would further delete all the pods for us. Hope this video was helpful, and we thank you for watching. Hello. We'll see how to create a deployment object and how it works. Let's look at our sample manifest for the deployment object. We start with the API version, and it is going to be extensions /v1 beta 1, which we can also find using the kubectl explain deploy command to know what the API version is. So we can give head to see the version of it. Yeah, so this is going to be the API version, and this is going to be the kind what we have to give. So let's quickly go ahead to the manifest again, and now we see the name of the deployment object. So we have given this name, so you can choose any name that you wish, and the number of replicas that it is going to contain is 6, which means that it is going to launch 6 pods and control them. The selector match labels is the important section wherein we specify a label key value pair, and this has to match with the label section of the pod, which is given inside the template section. And there comes the pod spec, in which we specify what container image we want. We give a name to the container, and we call the image name, and this image is going to be pulled from the Docker Hub. So let's modify the manifest slightly so that I can use the nginx image, nginx, Control X, Y. All right, so let's look at the changed manifest, and let's create the deployment. The deployment object is going to be created, and we can check its status now. It's ready. 6 out of 6 is ready. So which means all the pods should be running now. Get pods, all of them are running. And it has taken its name. All the pods have taken the prefix from the deployment's name itself, deploy-kubectl. We have got Nginx image inside this pod. We could change it to some other image like this. So let's say we want Apache image instead of Nginx. I'm going to put httpd, which is the image for Apache. Control X, Y, and I'm going to change the deployment configuration by using the apply command. So it's changed. Now let's check the status of the deployment. Using the rollout status command, we call the deployment object. Before that, we need to put the object type 2, which is nothing but deploy or deployment, in both the same. Deploy can also be used as a short form. So it says that it is successfully rolled out. So this is one alternative way of knowing if the deployment is successful. We can also give get deploy. And there's one more command which we can use to see the rollout history for this deployment. So we see that there are 2 revisions. The first time we created it, and second time we changed the image from Nginx to Apache. And now let's try to describe one of the pods. Here, we should have some details about it, like what it has got, the secrets in it, the events associated, and what image it is running right now. The event shows that it is pulling image httpd, which is nothing but Apache image. So it is currently running Apache. Now let's say we want to undo the rollout. We want to go back to the first rollout wherein we had Nginx instead of Apache. So we can use the rollout undo command, kubectl rollout undo, followed by the deployment, which is nothing but the object type, and then the object name, which is deploy-kubectl. So we are going to undo the deployment. The deployment is rolled back. We can check the rollout history again by using the rollout history command for the deployment, followed by the deployment name, and we see that something has got changed. Now we are at revision 3. And we could also check the status of it. The status says that it is rolled out. Now let's see the list of pods. And now let's try to get into one of the pod. Try to describe one of the pods. Control C, Control V. I'm just copying, pasting. Yeah. So now we have got Nginx container. So this is how we will roll out. Also note that creating a deployment will also create a replica set under it. So if you give get rs, the short form for replica set, you should be seeing that there is a deployment. There is a replica set which is created with the prefix deploy-kubectl. This is nothing but the replica set which got created because of the deployment. So if you delete the replica set, I'm going to delete everything. We should be seeing another replica set. This is because the deployment object which is on top of the replica set is going to create it for us. So this is added control. We already know that with the replica set, we delete pods and the replica set is going to create the pod. But here, there is one more object on top of replica set which would control the replica set itself. So deleting the replica set would also be controlled by a deployment object which would recreate the replica set for us. Now, in order for us to do a complete cleanup, we have to delete just the deployment, and the deployment object will be created. The replica set that it created will also be deleted, and the pods that the replica set created for us will also get deleted. So let's go ahead and delete the deployment. So we have done the cleanup. So let's see. no deployment is found, we can also use the get all command to list all the resources in this namespace, and we only see a default service which got created when the cluster got created, and we don't see any deployment replicas or pods. So in this video, we have seen how to create a deployment. We tried to explain the manifest file of it. We tried to roll out. We tried the history command, the undo command. We finally did the cleanup. We hope this video was helpful for you, and thank you for watching. Hello, we'll see how to create HPA, horizontal pod autoscaler object, in this video. The prerequisite is some understanding of deployments. So I'll show you the deployment manifest first. So we are going to create a deployment which will further create 3 pod replicas, each with Nginx image. Each has a container with Nginx image in it. So let's go ahead and create this deployment. The deployment is created. Let's see its status. 3/3, which means 3 out of 3 are ready. We can also see the number of pods. We have got 3 pods in this deployment, all running successfully. Now, we know that we have given the replicas as 3, which means that it would only create 3 replicas. And in future, if we wanted to increase the number, we'd get into the file and manually increase it to say 5 or 7 or 10, however we want. But there is a different object in Kubernetes which could handle this in a dynamic way. That is nothing but the HPA, horizontal pod autoscaler object, and we have got a sample manifest here to create it. So APA version is something which we can note from the explain command. So if you give kubectl explain HPA, you would know what the APA version and the kind is for this object, and you could copy it from there. So now let's get into the manifest again. So in the manifest, inside the spec, we are saying that the minimum number of replicas is going to be 5 and maximum is 7. Even though we gave it as 3 in the deployment, we are saying it has to be 5 and 7 just to illustrate the use of it here. And what is the condition is what comes next. The CPU utilization on the worker node should not exceed 75%. This is a threshold that we are setting for this object. And what are we going to scale? What is our target? Our target is going to be the deployment. Here, we are also including the APA version of the deployment, which is nothing but extensions v1 beta 1. Again, we can use the explain command to know what the APA version is for deployment. And what is the name of the deployment is what we have specified at the end, which is nothing but deploy-kubetrain, which we created few moments earlier. So this is what we need to give here, and this deployment has to exist so that the HPA can work. So let's go ahead and create the deployment. The HPA. The HPA has got created. We can check its status by giving the get HPA command, and we see that the replicas is still 0. So we'll have to wait for some more time until we see some number on the replicas section. We could also use the watch flag to see a live result. So now it shows 3. 3 means as of now it has got, the deployment has got 3 replicas inside it, in the manifest, but we are saying the minimum has to be 5 and maximum has to be 7. Let's go ahead and check the deployment to see if there is any effect on it. So get deploy has got 5 out of 5. Even though we gave 3, it has come to a level of 5, which is the minimum number of pods based on the CPU utilization. So which means that as of now it has got 5, and this number can dynamically change. If you reduce the CPU utilization, this could even go up to 7. As of now it has got 5, which means that as of now it is able to, the worker nodes are able to serve up to 5 pods. So it has increased. This is the effect of HPA on deployment, and we try to illustrate this with an example here. In order to clean this up, clean what we have created, we could go ahead and delete the HPA by calling the HPA name here after the HPA term. So what we gave is kubetrain, and we could also go ahead and delete the deployment. Delete deploy, and then the deployment's name is nothing but deploy-kubetrain. So what we created is deleted. So in this video, we have seen why we need HBA and what it can do for us in conjunction with an already existing controller object such as deployment. And we showed you how it increases or decreases the number of pods by specifying the required configuration in the manifest of the HBA. Hope this video was useful, and we thank you for watching. Hello. In this video, we are going to see the topic cluster IP, which is one of the service types in Kubernetes. It is good to have some understanding of deployments before starting this. So we are going to create a deployment first of all, and I'm going to show you the sample file, a manifest which is going to be used for creating the deployment. So the file is here. So I've already created it for you. I'm just going to show you. So this is going to be the manifest using which we are going to create the deployment. Since we said that it is good to have some understanding of deployment for this lab, we are not going to explain too much about the deployment itself. So let's go ahead and create the deployment by using the create-f command. Okay, so the deployment should get created now. Let's check its status by using the kubectl get deploy command. So we have it. We see that 3 out of 3 pods are ready. We can also see the pods, the list of pods, by using the get por pods command. So we have got the, there is one more pod which we don't have to be concerned about. So the pods that we need for this exercise is the first 3 pods, which start with the word deploy, followed by the hyphen, and then kube train. So these are our pods which we created just now. I forgot to use grep over there. Let me just use it now. Yeah, the pods are all running now. Let me give the get pods -o wide command. Let me delete the 4th one so that it's clear. By using the delete command, I'm going to delete the unwanted pod that we don't need for this exercise. Yeah, I just deleted it now. Let me give the get pods -o wide command again. So if you see, we could see the list of pods, the names of the pods, the IPs of the pods as well. And if we delete a particular pod, for example, if I have to delete the first pod, let me decrease the screen size before I delete it. Yeah, just to pick the phrase from there. I can use the delete pod command, and if I copy paste the pod name, I should be able to delete the pod. However, we know that the deployment is going to create this pod again for us. And let's give the same get pods -o wide command again. This time we see that a new pod has come, but the IP is getting changed. The name is also getting changed. The IP is also getting changed. So if you see, the first list of IPs were 13, 19, and 20. And this time we have got 19, 20, and 14. So 13 got deleted and it got replaced with a new IP, which is 14. So which means that pods are ephemeral, and so their IPs are. The IPs are getting changed when a pod gets deleted or terminated. So in order to keep this concept stable, like we know the pod IPs are not going to be stable, we can have a concept called a service using which we can keep the IP kind of stable. We can group these pods, 3 pods, into one single entity called as a service, and that service is going to have one IP. So let's go ahead and create a service manifest. SVC kube train. Okay. So before creating, I can also show you what the API version should be for SVC. So kubectl explain SVC is going to give some details about it, and we come to know from here that the version is going to be v1 and kind is service. So now let's go ahead and create the manifest for our service. svc-kube train.yaml. So API version is going to be v1, kind is going to be service, metadata like we give for other objects. We can give a name for this. We can call it svc ci cube train. So CI is I'm using it just to ensure that it is used for cluster IP, just to identify it. So and then we got the spec, and inside the spec we are going to use the selector here, just like we use for deployments. But here we will not be using the match labels phrase. We directly call the label which we gave for the deployments or the pods. So we gave something like tag, and then we gave label cube train. So selector is also there, and that's it. I think, yeah, we have got the pods now. So the pod which we have launched using the deployment is nothing but Apache, which runs on port 8080 by default, since HTTP uses 80 by default. So here we can give something like a list of ports. So to start with, we can give some name to it. So this is the Apache port, Apache, and we can give it, or let's go with something like this. Name is only for our identification. We can use anything we want. So I'm going to use something like port CI cube train, and under that I'm going to call the port, which is nothing but the service port. So this service port can use something like 8080, which means the port on which the traffic hits this cluster IP service. And we can use the target port, and the target port is nothing but the port on the container. And I've told you that 80 is the default port which is used by Apache for the HTTP service. And we can also give one more thing, but for this case it is not essential though. We can give something like type, which is cluster IP. In this case, anyway, cluster IP is going to be the default service type. So even if you don't give it here, it is going to work. So Control X, Y, we saved it. We are going to create the service now by calling the file name. Let's see if it gets created or if it throws any error. So I think the service is now getting created. Let's look at the status of this service by using the get svc command, and we can also specify the name of the service if we want. Cube train. So get svc. So we have got the cluster IP here. So the cluster IP is assigned, and this IP is going to be stable. So even if we delete one of the pods, it doesn't matter. The cluster IP is going to remain stable, and it is going to have a group of pods under it. So which we can see by using the get EP, which is nothing but endpoints command. And the endpoint object is also going to have the same name like this, like the service, which is nothing but svc ci cube train in this case. So let's look at the endpoints, and we see that it has got 3 ports ending with port 80. Each endpoint is going to have an IP as well as the target port, which is nothing but the port on which the container is actually running. So we have got the cluster IP here. So this is how we create cluster IPs. Hope this video was useful, and we thank you for watching. Hello, in this video, we are going to try to access the cluster IP. This is an add-on video to the already published video on cluster IP, but in that video, we have not seen how to access the cluster IP. So we thought we would put a supplementary video to show how to access it using curl. Let's check the list of services in this cluster by using the get svc command. We see that the cluster IP service is already running with the name svc ci cube train, and we have got a cluster IP. So please make a note of this IP, and we need to curl this IP followed by the port number. So in order to access this, we need to log in to one of the worker nodes of this cluster, and we can use the gcloud compute instances list command to see the list of instances in this current project. We have got 3 nodes, which are nothing but the worker nodes of this cluster. So let's try to copy one of the worker nodes name, and we can SSH into that using the gcloud compute SSH command followed by the node name. it would ask to confirm the zone. So in this case, we have been using Asia Southeast 1B. This is wrong actually, because we are using Asia East 1B, which is evident from the output above. So we need to change the zone. So I'm going to give no. So I've logged into this now. So it has used Asia East 1B as the zone, and it logged in to the worker node. So let's try to curl the IP. Okay, I think I have not copied the cluster IP. So let's exit out of this node once. Let's try to get the service IP. Let's copy that 1064.5.119, and let's try to get into the worker node again. I say no, because the zone is different. And now let's try to curl the IP followed by the port name. We need to put the colon after the IP to specify the port number, which is 8080. So we see the Nginx homepage by accessing the cluster IP. So this homepage is nothing but the page which is present inside one of the pods which are exposed by the cluster IP. We thank you for watching this video and hope it was useful. Hello. In this video, we're going to see how to delete objects. The syntax is going to be pretty much similar for all the objects. So it would be something like kubectl followed by the verb, which is nothing but delete, and then the object's name, object's type, which is pod or deployment or replica set or service or anything. So if we have to delete a pod, we'll have to give something like PO, which is the shortcut for pods, the alias, or we can also use pods or pod, either in singular or plural, followed by the name of the pod. So now we are on a cluster, and if we have to see all the objects that belong to this default namespace, we could give something like kubectl get all. And we come to see that it has got 3 pods, which are part of the deployment, and 2 services. One is the default service. So even if you delete it, it is going to be recreated. And we have got a load balancer service, a deployment, which is actually controlling the other 3 pods which you created. And then there is a replica set, which was created by the deployment too. So to keep it short, there's only 2 things that we need to delete in order to delete the manually created objects in this cluster. The first one is deployment. So in order to delete the deployment, we would give something like kubectl delete deploy, which is a shortcut for deployment, followed by the deployment's name, which is nothing but deploy hyphen kubetrain. So we get the name of it from here. So deploy hyphen kubetrain is the name of it. So we are going to delete it now. It got deleted. So if we have to check the list of objects again by giving get all in the default namespace, we now see only two things, which is the first one is the default, the service which got created automatically by the Kubernetes cluster. So we don't have to delete it. We just need to delete the manually created service, which is service svc-lb kubetrain. So let's delete it by giving kubectl delete svc, which is the shortcut for service, and then svc-lb kubetrain. So the service should now get deleted, and let's go ahead and give again the same command kubectl get all. So we just see one service, which is the default service, the cluster IP service that gets created when the cluster got created. So this is how we would clean up objects, manually defined objects in Kubernetes, and we could delete any object in this way. Hello. In this lab, we will configure a pod with an empty directory volume, which is a non-persistent volume type in Kubernetes. So I will show a manifest for a pod with empty directory, and I'll try to explain you the lines in it. So we are going to create a pod, and we know that the API version is v1 and the kind is capital P, pod. We're giving a name to the pod by specifying a name inside the metadata section. And then we have got the spec for the pod. We have the container section wherein we call an nginx image, and we are mounting a volume in this directory /mnt as specified in the mount path section. We have also defined a volume. We can define a number of volumes, but in this case, we only have a single volume defined in the spec of the pod, which is named like this: vol-empty directory dir-cube train, and this is of type empty directory. So we need to put D in big letters followed by a colon, and we just put two flower brackets to specify that it is an empty directory. We call the same name inside the container's volume mount section by keeping the same name here, and we could mount it to any directory as we want. Let's go ahead and create this pod by using the create-f command. The pod has got created. Let's use the kubectl get pods command to see its status. It is running successfully right now. Now let's get into the pod by using kubectl exec command -it and then the pod's name followed by bash to get into the bash prompt of the pod. We are at the bash prompt of the pod, and we could see the contents of the mnt, the mount directory. There isn't anything as of now. We could go ahead and create something by getting into the mount directory, and we can put some sample text into a sample file. So I'm going to say echo test text, and I'm going to put this information into a file called as test.text. So we now have the test.txt file inside the mount directory, and we could also look into the contents of it. So what we typed is there inside. We could now get out of the pod. Let's get into the pod again. When we say pod, we are actually getting into the container, which is inside the pod. And in this case, we only have one container. So we are actually getting inside the container, that single container, when we exec into the pod. So we'll use the same command, the kubectl exec -it command, and we get into the pod, the container. Let's see the contents of the mount directory. We should still find the test.txt. Now let's kill this container by using the kill command, kill1. One is nothing but the process ID, and the process ID for the container itself is number 1. There might be a number of other processes too, but if we use 1 and we kill it, we are actually killing the container itself. So we kill 1, the container is terminated, and we are out of the container. And if we give the kubectl get pods command, we should see the pod is running. Because the pod is running, it has restarted the container. Let's try to get into the container, the pod again. Yeah, I need to put exe -it and bash -it. After the pod name, I give bash. So we are actually getting into the container even if we give the pod's name. So we are in the container's bash prompt, and let's see if that file, what we created earlier, exists. It is still existing, which means that the empty dir volume type is persistent with respect to the container. If the container is terminated for whatsoever reason, the pod is going to recreate the container and the empty dir volume is still existing. So whatever content we gave inside the empty directory volume still exists. So it is persistent with respect to the container. Now let's exit out of the container, and now let's try to delete the pod itself by using the delete command. So kubectl delete po for pods, followed by the pod's name, which is po -empty dir -cube train. The pod is deleted. Now we can try to create the pod again. So we shouldn't be having any pods as of now. We can try to create it again by using the same -f create -f command which we used earlier, and we can specify the file's name. So the file's name is what? po-empty, yeah, this one. So we need to kubectl create followed by the file name. So this time the pod is going to be created again. Let's see the status of the pod. It's running. And now let's get into the container inside the pod again. I need to put the file name, the pod's name, followed by bash. Let's see the contents inside the mount directory. So there isn't anything now because the pod restarted, the empty directory is terminated. The content is no longer there. So we say the empty directory volume is non-persistent with respect to the pod, but it is persistent with respect to a container, because if a container gets killed, the pod is going to recreate it. So in this video, we watched how to create a pod with an empty directory, and we tried two different cases. We tried to recreate a container. We saw the empty directory pod was there. We tried to recreate the pod, and we saw the empty directory contents are no longer there. Hope this video was helpful, and we thank you for watching this. In this video, we're going to see how to configure a persistent volume with a pod. Let's look at a sample pod manifest, which we are going to use for this lab. So we are going to create a pod with the Apache image in it. So HTTPD is the HTTP daemon, which is nothing but the Apache image. We are going to mount a volume in this container at this directory /temp/Apache. And this volume should already be existing or defined inside the pod with the same name. So this name should match with this. And here we define what type of volume it is going to be. So this volumes, if you see the indentation, it is after the spec section. Just like containers is one section of spec, and volumes is another section of spec, so which is nothing but a section inside the pod spec. The name of the disk that we are going to use here is defined here as disk-gcpd-cube train. So when we create a pod with this manifest, it will search for a GCE persistent disk with this name and would get created if that disk is available and could be mounted. Let's go ahead and create the pod. The pod is being created. Let's check the status of it. It says container creating. So let's dig deeper and try to find the events associated with the pod using the describe command. So we see that the GCE persistent disk is not found, and that is why the pod is not able to run. So we need to create this disk. Since the disk is not existing, the pod is not running. So let's create a disk in Google Cloud using the G Cloud compute disks create command. So we could name, we have to name this like what we gave inside the pod spec. And we also have to specify the zone. The zone which we are in is Asia-East 1B, where all the nodes are functioning as of now. The nodes that belong to our cluster are part of this zone. So we have to specify the zone where we can call this disk from. The disk is about to be created with the default values. We are not modifying much of the information inside the disk. So it is going to create a 500 GB disk for us, and this is a persistent disk. Let's check the status of the pod again. It still says creating. Let's check it again. Let's try to describe the pod and just to see if there is any new event. Okay, so I think it's got succeeded now. The GCE, yeah, it says the successful attach volume dot attach succeeded for this volume. So the container still says creating. So it may take some time, as it's a big disk, it's a 500 GB disk. It could get some time to actually attach the pod, the volume to the pod. So let's try to describe the pod again. So we need to give the describe pod command followed by the pod's name. And now we see that, okay, so it has got a series of events. The volume get attached, and then later on there was a problem in mounting it, and finally the image was created successfully in the form of a container, and now the container should be running. Let's see the status of the pod quickly. Yeah, it's running now. So we have got a pod with a persistent disk in it. So in order to illustrate how this disk is persistent, let's try to get into the container by using the exec command and calling the pod name, followed by bash. Okay, so we were using TMP Apache for the mount. So we don't have anything as of now here. Let's get into this directory and let's try to create a sample file here. So I'm going to say echo test text, and I'm going to place this inside a file called as tst.txt. So if I look at the content of this file, I should be having this. So the file is ready. We have updated this directory inside the container, and this is actually mounted. The volume is actually mounted to this directory. So now let's go ahead and kill this pod. Get pod. So I'm going to delete this pod using the delete command, followed by the name of the pod. So the pod should now get deleted. And let's try to create the pod again by calling the file which we used earlier, the manifest. So we are creating it. Let's check the status of the pod. It's creating the container. It's at the container creating status. We can also use the watch flag to see the live status of it. Whenever the container creating changes to running, we see it here. So Control C. We know that now the pod is running. We could get into the container again, the container inside the pod again. Since we have one container, we exec into the pod, we are actually getting into the container inside the pod. So exec -it po gcepd and the name of the pod, not the file name, just the name of the pod, followed by bash. Let's see if the file still exists inside the temp Apache folder where we mounted the volume. It is still there. We can also look at its contents using the cat command. So cat test.txt, we see the test text content which we added to the file through the gcepd. So this proves that the persistent volume attached to a pod helps retain the content inside the volume even if the pod gets deleted or recreated. Hope this video was useful and we thank you for watching this.
We're going to use a secret object as a source for the pod's volume. The prerequisite of this video is to have some good understanding of secrets, pods, and volumes. So let's look at the secret objects manifest before we create it. So we're going to create a secret sample object, a secret object with the name secret-sample, which is going to have 3 data elements in it: animal, bird, and car, with their respective values: elephant, parrot, and jaguar. Okay, so let's now go ahead and create the secret object. It has got created. Let's see if it is there. Yes, it exists. Its name is shown here, secret-sample. And now we shall be creating a pod. And before that, we look at the manifest of it. So the pod's name is going to be pod-sample. It is going to have a volume inside it, whose name is volume1, and it is going to refer to the secret object that we created earlier. The name of it is secret-sample. And the container inside it is going to be an HTTPD container, which is Apache. And we are going to mount the volume that we specified earlier, the volume1, in this mount path. So this is going to be the mount path, and the name of the volume mount is volume1, which is nothing but the volume that we gave here. So it has to match the volume1 that we gave here, has to match with the name we give here. And the mount path is going to be this. So let's now go ahead and create the pod. The pod is getting created. So let's see if it is running. I think I gave a typo. It has to be an L at the end of the kubectl command. So it's running now. We can now execute, we can now SSH into the pod. We can now get into the pod to see the contents inside. So kubectl exec it and the pod's name, which is pod sample, and -bash. So we are getting into the bash prompt of the container inside the pod. Since it is only one container, we don't have to specify the container name. It's enough if we specify the pod name to get into the pod. All right, so now let's see the mount path. The mount path is nothing but temp Apache, so which we gave here, this one. So enter. You find 3 files. These files correspond to the keys of the secret element. The secret object has got 3 keys inside: animal, bird, and car. So it is going to create 3 files with the names of the keys. And the content of these files is nothing but the values of the keys. So if we have to look at the content of animal, we should find elephant in it. So we could also use one more echo to print it nicely with a new line character. Yes, elephant it has got. And if we have to see, similarly, if we have to see the bird file, we should have dove in it. Okay, parrot. Yeah, dove was for the config map example. So this is parrot. And what else is there? Car is there. Car. We have got jaguar. Okay, so this is how data from the secret object has got imported into the container through a volume. Now let's exit out of this container and let's go ahead and do the cleanup. So delete secret, the name of the secret object, which is delete secret-sample, and now delete the pod that we created, and the pod's name is pod-sample. So this is how we did the cleanup. So in this video, we saw how to create a secret object. We already know that, so that was a prerequisite. But specifically, we saw how to import the secret object into the container through a pod volume by mounting the volume inside the container in its mount path. Hope this video was helpful, and I thank you for watching.
Hello, in this video we'll see how to create a daemon set object. The prerequisite for this video is some knowledge on pod creation. So let's look at our manifest, a sample manifest for creating a pod, a daemon set. So this is the manifest. API version is going to be extensions v1 beta 1 for daemon set. This API version is also the same for deployment. We have given this the name ds-kubetrain, and then in the selector section, just like a deployment, we say what labels we want. We have to select, and this label key value pair should match with that inside the pod. So this is the pod template. The template section tells what has to be inside the pod, and inside the metadata section we have something like the labels, where we specify the label key value pairs. So this key value pair has to match with what we have given here. And for this section, you can put anything meaningful, like you can say app nginx, or you can say app web, something like that. But we have followed this format in all our examples. We use the tag as the label key, and we put something like label ds as the value. And then we have the container section, wherein we say we are going to launch an nginx container in the pod. So when we create this daemon set, it is going to create one pod, one replica nginx pod on each of the available worker nodes. So in order for us to see how many nodes are available on this cluster, we can use the get nodes command and see that there are 3 worker nodes. So when we create the daemon set, the nginx pod will be launched, one pod will be launched on each of the nodes. So let's try to create the daemon set. The daemon set is created, and we can now check the status of it by using the get ds command, and ds is the short form for daemon set. So it says current tree ready 2. Let's try to give the command again, ready 3. So which means all the 3 pods are ready right now, and the pods should all be running. Let's check the list of pods in the default namespace. So we have got 3 pods, and all start with the prefix ds-kubetrain, which is nothing but the name of the daemon set. So all of them are running. So this is how the daemon set is going to create one pod for us on each of the nodes. If we delete, for instance, if we delete one of the pod, so I'm going to pick the first pod, Control CV, and I'm going to, it is not -f, I'll have to say PO for pods. This pod is deleted, but the overlying daemon set object, controller object, is going to create one more pod for us. So let's see the list of pods again, and we should see a different pod right now. So we see that 2TP2K, the suffix, this pod got deleted and it got replaced with something new. So RF6RJ is there. We could also give get pods -o wide to see the information of the nodes on which these pods are running. So it is evident that each pod is running on a different node. So this is the first node, this is the second node, and we have got the third node here. So one pod on each node. So this is the concept. So let's do the cleanup by deleting the daemon set. So I can call the name of the daemon set, which is kubetrain, ds-kubetrain, and this is going to delete the daemon set for us. And if we now go and check the list of pods, it says it is terminating. Check again, terminating. So deleting the daemon set is going to delete the pods as well, and it should all get deleted in some time. So in this video, we have seen what a daemon set object is, how to create a manifest for the daemon set object. And we tried to explain the details of it, and we created a daemon set with an Nginx pod, and we'd also seen deleting a pod would recreate it because the daemon set is going to recreate it for us. And finally, we try to delete the daemon set itself, which is going to delete the pods for us. Hope this video was helpful, and we thank you for watching. Hello, in this video, we'll see how to impose CPU limits on the container inside a pod. Let me show you a simple pod manifest for this purpose. So in this manifest, we have a section called as resources inside containers. So in the resources section, we have two things called requests and limits. And inside the requests and limits, we can give some information such as CPU, memory, and so on. In this example, we are going to see the CPU section of it. So when we say CPU is 2 under the requests section, it means that the worker node on which this pod is going to be launched needs to have at least 2 CPUs to accommodate this. So we tell the node, hey node, if you want me to be on your node, you need to have at least 2 CPU for me. You need to have this reserved for me. And what about the limits? Limits is on the higher side. CPU 3 means that, okay, this pod is not going to use more than 3 CPUs on the node. If it is going to use, it is not going to survive on the node. So this is how we specify requests and limits. In order to illustrate this, let's log into one of the worker nodes and see how many CPU cores we have got there. So gcloud instances list, because we are using Google Cloud, we're going to give this command to look at the list of instances, and all of these are the worker nodes for this cluster. Let's log in to one of the nodes by giving gcloud compute ssh command. I just say no n because I am in Asia East 1B zone, so I just say no. Yeah, so I'm into the right zone now, and I should be in the worker node, one of the worker nodes, and all of these worker nodes are having similar CPU configuration. So it's enough if I log into one and see how many CPU cores I've got. So I could use this command to find the number of CPU cores. So this is going to give me a whole bunch. So if I need only the number of cores, just to see the number of cores, I just grep it with this word, and I could see it now. It has got only 1 core. Let's get back to our pod manifest. So this is our manifest, and here we have given in the request section, we are saying that we need at least 2 CPUs. So even if we create this pod should not run because it does not find a node on which there is at least 2 CPU to accommodate this pod. So let's go ahead and create it. So the pod is created. Let's check its status. I need to give the object name, not the file name. Yeah, it is pending. It's pending again. So let's try to get more details about it by using the describe command. So it says it failed scheduling because 0 out of 3 nodes are available because of insufficient CPU. So this is how we have illustrated why the pod is not able to schedule on a node, because it couldn't get enough CPU on the node to accommodate this. This is just a manual way of doing things, and we set limits so that we could customize such options whenever we need them. This manifest could also be explored further, like, yeah, let me show you. Yeah, so inside the request CPU section, you could reduce it, or you could have more in number, and you could also use certain stress commands. Here we are using PO Linux as stress. So if you're good with stress Linux, you can get some stress commands to artificially increase or decrease the CPU once you are into the pod and experiment various things. But the agenda of this video is covered by showing you how how the requests and limits section is actually affecting how the pod could be launched. Let me just show you one other quick example by just modifying the CPU number, the number of cores, to 0.8 slight or 0.7, slightly less than the available CPU on the node. So Control X Y. Let me delete it. So I have deleted the pod. Let me just try to create it again. Yeah. Now let's see if the pod is running or not. It is pending too. Again, it says insufficient CPU. Okay, it might be because there are other processes running on the CPU too. So we could still reduce it further, and let's see now. We could still reduce it. So we can make it maybe a 0.2 or 0.5. Yeah, let's see now. So we have to delete it first. After deleting, we can try to create it again and see if that gets running up or not. All right, let's see if it works now. Container is creating. It's running now. So this is how we can experiment things with the requests or limits based on the target CPU utilization. So even though we saw the maximum number of cores is 1, everything may not be available for the pod. It could have some other processes running in it. But yes, we are not into that exercise wherein we could actually check the live utilization. We just wanted to show how we could change the limits or requests on the pod to get it running, or to see how it is failing. Hope this video was helpful, and we thank you for watching.
Hi, let's see how to add labels to nodes. There isn't much prerequisite except that you know what nodes are in a Kubernetes cluster. We have got 3 nodes in this Kubernetes cluster, and I'm going to add a label to the first node. So I can use the label command to label the node. So I'll say kubectl label, and I'll say node. After that, the node name followed by the label that I want to give. I can give it some meaningful name like environment is equal to testing. So this is one way of giving it. And let's say I want to label the second node, and this time I'm going to edit the live configuration of the node. So I'll say kubectl edit node and then the name of the node. So this will take me to the live manifest, the live configuration of this node, and I can get into the metadata label section, and I can add it here, somewhere here, like environment development. So for the first node, I give testing, and for this node, I just give development. And that's it. I'm just going to save the configuration and get out of the file. So the change is now committed. We can actually see if the label is there or not by using the get node command followed by the name of the node. I'm going to give the first node now. And if I have to see the labels, I'll just say show hyphen labels. So this would tell me all the list of labels in this node, and what we gave should also be present. So we may have to just search for that. Yeah, I think it is here. Environment testing, or we can also grep it. Yeah. So environment testing is present in this node. And likewise, if I have to give, or if I have to check for the second node, I'll just copy paste the name of that node and say show labels. And this should also have the label that we added, but we used two different ways. We used the label command, and we also tried to change it using a live manifest. So that's about this video. We can actually use this for selecting pods, scheduling pods on nodes of choice using the label selector that we added in the nodes. Hope this video was helpful, and thank you for watching.
Hello, in this video we're going to see another video on taints and tolerations, but this time we are going to try a new effect, no execute. So there are three effects: no schedule, prefer no schedule, and no execute. We have already seen no schedule in a different video. So in this video we are going to try no schedule as well as no execute, just to see the difference between these two things. So this is the manifest that we have got for the deployment. Let's go ahead and create the deployment. And one node is already tainted with the toleration that we see on the screen. Let's create the deployment. The deployment is being created. Okay, we need to delete everything first. And I'm going to create it again. Let me check if the pods are running successfully now. The pods are all running, and we could see all the nodes. So the pods are kind of distributed on all the nodes that are existing, and few of the pods are still getting created. Now let's go ahead and taint some other node, the second node. So we have got three nodes. I'm going to pick the second node, and I'm going to taint it this time with a different effect. So I'd say taint, I'd say node, and paste the node's name. And after that, I have to put the key. I can choose something like taint key 2 is equal to is the operator, and I'm going to put the value. It can be taint value 2. And after that, we have a colon, and we specify the effect. So I'm going to say no schedule to this. So no schedule is already seen, but just to illustrate the no execute effect and to see the difference, I'm going to use no schedule for this node too as well. So this node is also tainted, but there shouldn't be any change with respect to the pods. We should still be able to see pods on this node which got tainted just now, even though the pods do not have a toleration for this recently created taint. So we can grep it. We can try to grep the prefix prg4, and we see that the pods are still running on this node even if we tainted this node. This is because the no schedule effect is not going to virtually affect any of the existing pods. Only if we create a new pod that is going to affect it. So for example, if I have to delete everything, if I have to delete the deployment, and if I recreate it, that pod is not going to be part of this node because that pod does not have an associated taint in it, toleration in it. But this was already seen in the video of no schedule. So now it should be clear that the no schedule effect is not going to affect any existing pods. Now let's try to taint the third node. So I'm going to copy the name of the third node, and I'm going to taint it now with a different effect. So this time I'm going to say the key as taint key 3 equal to is the operator, and the value is going to be taint value 3 with the effect no execute. So the effect is that it is also going to affect existing pods. Even if A pod that is running does not have a toleration for this respective taint, Kubernetes cluster is going to, this node is going to throw the pod out of it. So that is the difference between no schedule and no execute. So let's see this in action. Get pods. Yeah, so now we see that none of the pods are running on the third node. So what is the third node? Get nodes. So we have got the third node with z z4xc. So we can try to grep it. So get pods hyphen wide hyphen o wide, and if we wanted to grep z4xc, we don't find anything. This is because the pods that were existing in this node got evicted out of that because of the taint effect, no execute, even though they were running, and they got placed onto some other node which was available. So that is how this is going to work. So this, in this video, we saw the difference between no schedule and no execute. Although we have a different video on no schedule, we wanted to show the difference between no schedule and no execute. And we saw how the no execute taint affected existing pods, and the no schedule effect does not affect existing or running pods. But if a new pod has to launch, it is going to affect it. Hope this video was helpful, and we thank you for watching.
Hi, in this video, we are going to look at the node affinity feature, which helps pods to prefer launching on nodes of choice. So I'm at the Kubernetes API reference documentation, and let's search for the node affinity feature. So here it is. So this is for the volume node affinity. This is not what we want. Let's try to search again. And we should have something under this. Yes. So this is what we are looking for under the pods spec. I'm clicking on it. So here we have got two options. We are going to look at the first option that says preferred during scheduling, ignored during execution. So this is the topic for this video. So in order to make the better use of this video, it is good to have some understanding of deployments. Okay, so let's see what we have got inside this. So this is an API reference that should help you configure the pod based on the reference, so that you don't have to remember things, and you can use this documentation to look at what are the various options inside. Let me just go ahead to the CLI where I have got the cluster ready. So this is the master I've launched. I've logged into the Kubernetes master, and let me just check how many nodes are present in this cluster. By using the get nodes command, I see that we have got 3 nodes and 1 master. And if I have to see the labels on each of these nodes, I can use the show labels flag. So I'm going to get a list of labels on each of these nodes. And for this exercise, we are going to use the label that says kubernetes.io/hostname. So we are going to use this label for the purpose of this exercise. I'll tell you why. Yeah. And let's use this one. So let's say we are going to launch all the pods on node 0, and we have got this one, which is called as kubernetes.io/hostname is equal to k8s node 0, which specifically identifies this node. And this label is kind of unique. If you look at other labels, they might be common. Like, for example, if you look at the beta Kubernetes IO architecture label, it is going to be there on all the nodes. So this is not very unique in this case. Okay, so let's now try to define a deployment. So I've got a deployment configuration. So let's see what we have got inside. So this is a deployment which is going to create 20 replicas of the pod. And this is the label selector. So that is why we said it is good to have some understanding of deployments before we start this video. I mean, before you look into this. And this is the main area of focus for this video. So this is where we have defined the affinity in specific node affinity, and we have used the preferred during scheduling option. preferred during scheduling, ignored during execution. And these are the options inside this section. So this can be referred to from the other API reference documentation, which I showed you initially. So you could check all that from there. So if you look here, so you have got this preference and you have got this weight. Weight is nothing but a number, an integer that is associated with this particular preference. So you could give a number starting from 1 until 100. And this is going to be of use when you have multiple preferences and each preference having its own weight in order to choose from one of the available preferences. But in this exercise, we are only going to use one section here, one weight and preference, that's it. We don't have any other item. So we can go with the the basic value, the lowest value, which is weight 1. That should be fine in this case. And what we have got inside preference, we have something called as match expressions, and which is nothing but a label, kind of a label selector. So I've already shown you the labels on each of these nodes, and in specific we are going to use the label key, which is kubernetes.io/hostname, and the operator in says that it has to be one among these values. But here we are only going to use one value, which is k-test node 0, but we could use more than one value here. So this means that all the pods in this deployment are going to prefer node 0. They're going to be launched on node 0 if it is available. They're going to give it the first preference. So let's go ahead and launch this deployment using the kubectl create command. All right, so the deployment is now created. Let's look at the status of this deployment. We have got 5 out of 20. So now it is 14 out of 20. We can also use the watch flag just in case you wanted to look at the live status. Okay, it's 20 out of 20. If we have to see the status of the pods, we could use the get pods command, and we're also going to use the -o wide flag so that we know on which nodes these are at the moment scheduled. So if you see, the pods are getting scheduled on all the nodes. It has got node 0, it has got node 1, it has got node 2, even though we preferred node 0. Okay, so if at all we wanted to see the pods that are only on node 0, we could grep it, we could filter only the node 0, and let's see this. So we have some nodes which are already here. And if we wanted to see a count of it using the wc command, the word count, let's see what we get. So we get 10. The first line stands, the first entry here tells you how many lines you have got, which means it is 10 lines, which is nothing but 10 pods. So out of 20 pods, we have like almost 50%. We have got exactly 50% of the pods, which is 10 pods that are launched on node 0, which means that it has given it the best preference. Only the rest of the pods, got scheduled on node 1 and node 2. This is because when the default scheduler of Kubernetes tries to schedule these pods, it would look at available pods and also gives it a preference, and accordingly, it has placed more number of pods on node 0. So this is how this option, the soft preference, which is nothing but the preferred during scheduling option, is going to work with node affinity. So with this, I think we come to the end of this session. We've demonstrated how to use this option, the node affinity option, which would allow you to go with a soft preference. Let's do the cleanup. Deploy, and we have created a deployment called let's deploy 25. So we are going to just delete it. Sorry, I gave a typo. I should be yeah, I think I missed one command, which is delete. So delete, it isn't there, isn't it? So let me check what we have got. Oh, sorry, yeah, it's 35, it's not 25. So 35. I've deleted everything now. So we have cleaned up what we created. So in this video, we have seen how to use the node affinity feature within the pod spec, and we saw how to make sure we give soft preference to it, meaning we are gonna prefer something for the pods. Like, we're not going to give it a hard requirement, rather we just give a preference for a particular node. Hope this video was helpful, and thank you for watching.
Hello, in this video, we're going to see about role bindings. Role bindings are nothing but mappings of
subjects such as users with roles. The roles define the permissions that the user can actually do. A prerequisite for this section is to have some understanding of user management. There should be a video covering user management separately. All right, let's look at the manifests that we have got for creating a role and then a role binding. So this is the manifest for the role, and the API version is going to be RBAC. Whatever text you see, the API version is going to be the same for both roles and role bindings. The kind is going to be a role with a big R, and metadata, you just give a name for this role. And you can also specify a namespace under the metadata section, because this is a namespace resource. This resource, the role resource, is going to be scoped within a namespace. And then you would define rules, set of rules. And in this case, we only have a single rule. First, we specify the API groups, the list of API groups. The API groups is nothing but, they are nothing but the API version without the version. For example, the API version for pod is /v1. So we didn't have to give anything before the version number. For example, if you see here, kubectl explain pod, and if you want to grab just the version, you would see v1. So you don't have to specify the version number here. So the API group is nothing but nil text. There's going to be nothing. So that's why we have put two quotes here without anything inside. And resources is nothing but pods, because we are going to refer to pods here. And the verbs is list. So this role should give us permission to list pods in the default namespace, because we have not specified the namespace in the metadata section. This is going to refer to pods only in the default namespace. All right, now let's go ahead and create this role. The role is created. So get roles should give you this role that you created seconds back, few seconds back. All right, now let's look at the manifest for the role binding. A role binding is also a namespace resource. It is scoped within a namespace. The API version is going to be the same, just like rules. Kind, you need to give big R and big B. And metadata, just give a name for this role binding. And you can also specify a namespace. Since you're not specifying a namespace, this means it is in the default namespace. Then comes the subjects. And a commonly used subject type is user. So we are going to call this user. We're going to map this user, and this user should already be existing. So user2 is already existing, and that is why a prerequisite for this video is to have some understanding of user management. So you should know how to create or add a new user. And the API group is the same for user, just that you don't have a version number here. So v1 is not there. So whatever comes before the version is going to be the API group. So the API group is going to be the same for roles, role bindings, users, and roles. All right. And now you need to map this user with the role. So the role is something that you created already, and you know what the API group of this role is. So this is going to be the same. So the API group is going to be the same, but you need to specify it. You're going to say that this is a role, a kind is role, and you're also going to call the name of the role that you created sometime back. And that's it. You have mapped user2 with this role. So after you create this role binding, this user2 should be able to list the pods in the default namespace, and it should not be able to do any other operation which is not explicitly mentioned. All right, now let's go ahead and create this role binding. The role binding is also created. Okay, so role is created, role binding is created, our task is over. Now we need to actually switch to user2. We need to switch the context to do so. So kubectl config use context to switch the context. And the name of the context is nothing but context2, inside which we have mentioned the username, its certificates, and so on. So this context is being switched so that from now, whatever commands we are going to perform using kubectl is going to be performed as user2. All right, now let's go ahead and list the pods in the default namespace. It's working. We don't have any resources, that's fine, but the command is working. We have permission to do so. Let's say we wanted to do something else. If we wanted to get the deployments in the default namespace, it shouldn't work because the role binding doesn't let us do it. So it does not have any permission to list the deployments. It only has permission to list the pods. So this is working as expected. With this, we now know how to create a role binding, how to create a role first and then create a role binding to map that with the role and with whatever permissions we want inside the role. So this is working as expected. Now let's do the cleanup by deleting the role and the role binding. So we don't know. I mean, in order to do the deletion also, we need to go back to the old context, which has admin permission. So with this user, with user2 as the current user, we may not be able to even look at the list of rules, right? So we are going back to the old context. So use context, Kubernetes admin at Kubernetes. This is the default context for the admin user provided by KubeADM. So I am switching back to the admin context, and now I'm going to look at the rest of role bindings first, and I'm going to delete the role binding first. So delete role binding user2, the name of the role binding. Okay, so the role binding is deleted, and now let me go ahead and delete the role. So get pods is the role. I'm going to delete it. Delete role, get pods. And that's it. We are done with the cleanup. So we saw how to create a role, how to create a role binding, how to perform operations as a different user, and then finally we did the cleanup. Hope this video was useful, and we thank you for watching. Hello. Let's see how to define a role binding with cluster role. A role binding is a namespace resource, whereas a cluster role is a cluster resource. So in this section, we'll see how to create a cluster role and later on map a user with that cluster role using a role binding. The prerequisite for this section is to have some understanding of user management. All right, now let's look at the manifest of the cluster role that we are going to create. So a cluster role is also like a role. The difference is that the cluster role scopes itself to the cluster and doesn't restrict to a namespace. The API version of a cluster role is also going to be the same like a role, and we are giving it a name list-ds, and there is no namespace in this case. The rules define that we are going to use the API group extensions because the API group for daemon sets in this cluster with this Kubernetes version is extensions. We don't have to specify the version number such as v1 beta 1 here. The resources is going to be daemon sets, and the verbs that we are going to use is only list. So this cluster role should help listing daemon sets irrespective of the namespace. So let's go ahead and create this cluster role. kubectl, just use the create command and call the file that has the cluster role definition. So cluster role is now created. We could check it. So it was created 37 seconds back. So the cluster role is there. It's time to create the role binding now. So let's look at the manifest first of the role binding. So this is a namespace resource. Even though cluster role is a cluster resource, role binding is still a namespace resource. So we haven't specified the namespace in the metadata section. So it is going to take the default namespace if it is not explicitly mentioned. The subject says that we are going to map the user, which is user2, and the API group is all going to be same for all the access control resources like roles, role bindings, users, cluster roles, and so on. So the API group is this. So user2 should already be existing in the cluster, I mean, in our kubeconfig. And the role ref, in this case, we are not using role, but rather we are going with cluster role, which means that we are referring to a cluster role instead of a role. The API group of the cluster role is also same. And list-ds is the name of the cluster role, which we created some time back. So now let's go ahead and create this role binding. So create -f, role binding, the name of the file. It should now get created. So this role binding should allow user2 to use the cluster role list-ds, and inside the cluster role list-ds, we have specified that user2 should be able to list the daemon sets in any namespace. The namespace was not specified in cluster role, but since role binding is still a namespace resource, we would only be able to list daemon sets in the namespace to which this role binding belongs to right now, which is nothing but the default namespace. So let's see this in action. Let's switch the context first. So config use context2. So this is where user2 is existing. So we are now user2, and let's try to list the daemon sets. The command is working. There is no resources, that's fine, but the command is working. But as per the cluster role has told that it doesn't have anything related to the namespace. But so that might mean that we should be able to list the daemon sets irrespective of the namespace. But that isn't true, because we are using role binding, which is still a namespace resource. So that is why if we give something like this, if you wanted to list the daemon sets of all the namespaces, this is not going to work because we have used role binding. Creation of cluster role is only going to help us leverage the cluster role into a role binding of any namespace. But the overall functionality is still going to be the same. So even if we have created a role binding instead of the cluster role binding, the end result is still going to be the same. But we don't have to create role bindings for each of the namespaces. So we would only create one cluster role, and we can try to use that cluster role with any namespace that we want inside the role binding of that particular namespace. So this is how role binding works when we are referring to a cluster role inside the role binding. So as usual, nothing else should actually work because we have not explicitly specified anything else other than listing the daemon sets. So if you wanted to list the deployments, for example, it shouldn't work. So it is as expected. All right, now let's do the cleanup, for which we have to switch the context back. So we need to switch to the admin context. So in this case, it is this. So this is the name of the context. We are switching back to the admin context, and now we are going to delete the cluster role and the role binding. So first of all, let's delete the role binding. So the role binding, the name of the role binding is what? So we can try to view it, right? I mean, we can see what all is there because this is still in the namespace, the default namespace. So we can delete it now. Delete role binding user2, the name of it. This is over. And now let's go ahead and delete the cluster role resource, which is a cluster resource. It is not a namespace resource. So we'll see. We'll try to see the name of it. I mean, if it is there or not. We'll just use the get command first. So cluster role, I think we gave this name. Yeah, it is there. It was created 6 minutes back. So now it is time to delete it. So we did the cleanup. So the cleanup is also done by switching back to the context. So in this video, we saw how to use a role binding, and we referred a cluster role inside the role binding. So this would make our life easier. We'd only create one cluster role, and we could refer to that cluster role to any number of role bindings, any role binding in any namespace we want, rather than creating a role in each namespace. We could create one cluster role, and we could call that cluster role in any of the namespaces inside the role bindings of that namespace like we want. So this would make things easier for us. The overall role-based access control mechanism is going to be a bit easier when we go with cluster roles inside a role binding. So hope this video was helpful, and we thank you for watching.
Hello, in this video, we're going to look at the cluster admin cluster role binding. And the prerequisite for this section is to have some good understanding of kubeconfig and the cluster role binding object. We know that when a cluster gets launched with kubeadm, there's going to be a kubeconfig that gets generated, and we also copy that kubeconfig at this location .kube/config. So kube is a hidden directory, and config is the file which holds all this information. And this content doesn't usually fit in one screen unless we minimize the screen font. All right, so in this config, we are going to have some user details, contact details, and so on. And in a fresh cluster, there's going to be only one user whose name is Kubernetes-admin. And this user has got admin permissions in the cluster. So in this video, we're going to actually see how this user is actually getting the admin role, the admin permissions to perform all operations in the cluster. So in the kubeconfig, there is also going to be something called as the client certificate data that is associated with each user. So we know that there's only one user in the config as of now. So if we have to grep client certificate data, this data is nothing but the data which is belonging to the user Kubernetes admin, because we don't have any of the user as of now. So we could just grep it. So we just grepped it. So we could also grep it in the reverse way. Instead of giving a cat, we could actually grep it like this: grep client certificate data. So I'm going to give a grep at the beginning like this. And if I have to grep it, I'll have to grep the word that I want and followed by the file name. So the file name is nothing but this. So if at all you use a different kubeconfig, you will have to specify the exact location of that so that you grep it. Okay, so this is what you get. Now, this is in base64 encoded form. We don't understand anything written in it just by looking at it, right? So we may have to, first of all, get just the data before we actually decode it. So in this section, we have got two things. We've got the client certificate data, which is like the key, and a value associated with it, which is nothing but the actual certificate. So we are interested only in the second part, the value of the certificate and not the key. So we could actually use the tool awk, and we could, let me clear the screen first. Okay, and now, so I'm just going to use the awk tool, and using the awk tool, I'm going to print the second section of the screen, so which is the value. So which is, I can use print $2 so that I just get the value. There is a typo. Let me correct it first. Print $2. Okay, and now I just get the value. I'm not seeing the key anymore. And now we have to actually decode it, because this is in base64 encoded form. Let's just decode it using base64 decode. So base64 -- decode. This is now decoded. So this is what you see in the decoded form. But even if it is decoded, this is all some text which we don't understand just by looking at it. If at all we wanted to see some details about it, we can use actually the OpenSSL tool, and we could get the details about this certificate in text form. So for which we can use the OpenSSL command like this. So I'm just going to pipe the previous command. So the previous command is this, and I'm just going to give one more pipe. And for this pipe, I'm just going to say OpenSSL followed by X509, because this is an X509 certificate. And I'll say -text. So this is a bit understandable. So in this content, we would actually see some details before this line, before the begin certificate line. There are going to be some details which would be in clear text form that helps us understand some details about this certificate. But in this section, in this case, we are only interested about the username and the group, because the username is Kubernetes-admin, what we saw before in kubeconfig, and this certificate should hold some information about that user somewhere. So that information is actually present in the subject section. So I'm just going to grep subject, but in your case, you can actually hover around. You can actually get this content, save it in a file, and you can look what all it contains. But for this case, I'm just going to grep only the subject section. So the subject section, I could even put one more colon to be more precise. Yeah. So the subject section tells me what the organization is and what the common name is. CN stands for common name and O stands for organization. So CN is actually equivalent to the username or the user, what we have inside the kubeconfig, and O is a group, which we don't have in kubeconfig, but O is actually equivalent to group. So this tells that this certificate is for the user Kubernetes-admin, and this user actually belongs to the group system-masters. So now we know that the certificate has got the details about the user and the group. And now this user or the group should have been mapped somewhere inside a role binding or a cluster role binding, because this is a cluster admin role. This is, this user has got admin permissions all over the cluster. So there should be a role binding which would actually map either this user or the group. So there is actually a cluster role binding which does it for us. So let's look at that cluster role binding now. Cluster role binding, and the name of the cluster role binding is cluster-admin. So this is a cluster role binding which gets created by KubeADM itself when you launch a cluster, when you bootstrap a cluster. So this is it. I think there is a, yeah, I'll have to give the verb, right? The verb is get. Yeah. So now we know that this cluster admin cluster role binding is existing, and it is existing since 18 minutes. If at all we need to get more details about this, about the cluster role binding, we could use the -o YAML, so that, let me clear the screen once. Okay. And now if I have to use -o YAML, I could get more details about it, the details in the manifest. Okay. I'll have to use get, right? Yeah. So get and -o YAML. So this is going to give me the complete manifest of this cluster role binding. So this should be already familiar to you, how a cluster role binding has to be defined. But here we are only going to look at this section which says name cluster admin. So this cluster role binding is actually mapping the cluster role cluster admin with this group system-masters, which we saw sometime back, which we saw, I think, a minute or back. So we saw that this group is actually representing the Kubernetes-admin user. So we have a cluster role binding that actually maps the group system-masters with the cluster role cluster admin. So now it's time to actually see what this cluster role contains. So I'm gonna give a similar command, but instead of cluster role binding, I'm just gonna say cluster role, and the name is same. The name of the role binding, the cluster role binding and the cluster role are both same. So cluster admin -o YAML. So this role should tell us what it actually does. So this is the role that helps, or that lets the user, Kubernetes-admin user, with all the permissions on the cluster. If you look at the wildcard, which means that all the API groups, all the resources, and all the verbs. And like that, it is also going to let the user Kubernetes-admin with all the verbs on all the non-resource URLs also. So this is a pure cluster admin role that lets the Kubernetes-admin user perform anything on this cluster. And this is how the Kubernetes-admin user is able to perform any operations in the cluster. And by default, this user gets created by KubeADM and it gives the administrator full admin role on the cluster. So we saw how the Kubernetes admin user was actually referring to the cluster role, cluster admin, and how the cluster admin role was in turn referred to in the cluster role binding, so that the Kubernetes admin user could perform admin operations in the cluster. Hope this video was helpful, and we thank you for watching it.
Hello. In this video, we are going to see about network policy objects in Kubernetes. The prerequisites would be to have good understanding of pods, deployments, and services. Let's go ahead and create a cluster. using the gcloud command line interface. So gcloud container clusters, and then we are going to say create. We can give this a name like cluster1, and we have to enable the network policy add-on like this. And after which we can also specify a zone if at all we need. So I'm going to call US Central 1A. Cluster should now get created. All right, now the cluster is created. We can generate the kube configuration, the kube config for this cluster, again by using gcloud. The gcloud container, the GKE, Google Kubernetes Engine. So we're going to say gcloud container clusters. And after that, we are going to get the credentials for this cluster, which we created just now. So we're going to say the name of the cluster, which is cluster1, and the zone, which is US Central 1A. So the kube config should now be ready for the cluster, and it is already synced. So using kubectl, I think we should be able to look at the cluster info. This should be working. Created now, yeah. So this seems to be working, and we can also try some other command like kubectl get pods. So there isn't anything in the default namespace. If at all we want to check a different namespace like kube system, we should be seeing a bunch of pods out there. Yeah, so this is all good. So the cluster has launched the GK. This is a GK cluster, Google's managed service, Kubernetes service. All right, fine. So the topic that we are seeing now is about network policies, right? So in order to illustrate that, we are now going to create 3 objects. Let's clear the screen. So these are going to be the manifests of these 3 different objects: a deployment, a service, and a pod. So let's look at the manifest of the deployment first. So this is a deployment which is going to create 4 replicas for the Nginx web server container. The pod, there's going to be 4 pods now. Let's go ahead and create this deployment first. So I'm going to call the name of the file. So this should now get created. And as the next step, or before that, let's validate. Let's verify if this is there. So get pods. So all the 4 pods are running, so it's quick. And now we need to create the service. So let's also look at the manifest of the service. So this is going to be a cluster IP service which will expose the deployment which we just created based on the label selectors. So let's go ahead and create this service now. File's name is, yeah. Okay. Service, I think, is also created. We can look at it, get service. It is existing, service 25CA at the bottom, this one. And we can also see if the endpoints are showing up for this service. So EP endpoints and SVC 25-CI. We see a bunch of endpoints, which is nothing but the list of pods, IPs, and the pods on which the web server is actually functional. So the service is created, deployment is also created, fine. Now, as a third step, we are now going to create a pod, a standalone pod, an Apache pod. So let's now look at the manifest of the pod. So this is going to be a simple pod, a standalone pod, which will run the HTTPD image, which is nothing but Apache. Let's go ahead and create it. So the pod is getting created. Let's see if it is running or not. It is getting created. Yeah, now it is running. Now what I'm going to do is, let me look at the list of pods again, and I'm going to execute. I'm going to enter into the Apache pod, and I'm going to execute a few commands there. So kubectl, I'm going to say exec -it, the name of the pod, which is Pure25 Apache, and let me get into the pod by saying -bash. So I'm into the bash prompt of the Apache container, And in this container, I'm going to install the curl utility. So I have to say apt update yeah, and now I'm going to install curl. Okay, so curl is now installed. So if I give curl, yeah, I think it's working. So let me clear the screen here, and I'm going to curl the service that we created. So let's exit out of this pod once, and let's look at the IP of the service. So the IP of the service is 10.35.250.40. So this is the IP of the service. So if we access this service from within the cluster, we should be able to reach the pods that are under this service. So I'm going to use Apache for that purpose. So I'm going to use Apache as the source pod from which I'm going to reach this target service. So that is why I created the Apache pod in a standalone way to illustrate this exercise. Now let me execute into the pod again, but either I can get into the bash prompt or I can also give the command straight away from the exit prompt itself. So if I have to say curl 10.35.250.40. 8080, the port is 8080, so I think I need to give colon 8080. Yeah. And I should be able to reach the homepage of the Nginx, one of the Nginx pods, which is the standard homepage out here, what you see. So the curl is working from this pod to the target Nginx pod. So this is good. This is working as expected. All right, now we don't want this to work like this. So we're going to restrict this network traffic. So we are going to add a network policy to stop this, to block this traffic, which is working already, to stop it now. And for that, I'm going to create another object, which is the network policy object. So let's look at the manifest of the network policy object. The API version is going to be extensions v1 beta 1, the kind N and P in big letters. Metadata, we can give any name like we want. The spec is important, the pod selector. Just like this is kind of similar to how we select pods from a service or from a deployment. So the only thing we have to remember is that we need to give pod selector, not just selector. And match labels, we're going to call the labels of the pod. So tag label 25. So this is going to direct to the pod, the Nginx pod that we created. So this network policy gets applied to the Nginx pod in the ingress direction. So it only allows inbound traffic from pods that would match these labels. So it will only allow inbound traffic from pods that match this label. If some other pod tries to access this, it will not work. Now let's go ahead and create this network policy. A network policy is created. We can also see its status. Yeah, the pod selector is there. It's fine. And let's try to curl again from the Apache pod to the Nginx pod. So I'm trying to curl the Nginx service, which is obviously one of the pods under the Nginx service from the Apache pod. And now it is not working. It is not working, right? I mean, the curl is not working because we said it is only acceptable from a pod that has this particular label, and we don't have this label in the Apache pod yet. So let me press Control C and let me quickly go ahead and see the manifest of the Apache pod. This Apache pod does not have any labels. I did not give any labels on this, right? So Control X, let me get out and see this label, tag label 25 Apache. I'm just going to add this label into my Apache pod right now. So here I'm going to say labels, and I'm going to add this new label. So 2 spaces to follow the YAML indentation. Label is now added. A new label has been added. So let's save this configuration, and now let's modify the existing Apache pod so that a new label gets added into it. We applied it. The label should now be there in the Apache pod. We can also kind of see the labels of this pod by saying get pods --show -labels. So we can also see the labels that are present in this particular pod for all the pods indeed. So this pod has got this one. So the pod 25 Apache has got this label because we just added it. Now let's clear the screen and try to issue the same curl command which we did before. So let me try to copy it from history. Yeah, so I can copy this, right? I can not this one, so I can use this. Yeah. So if I do this now, and let's wait and watch. It's working. We first created a cluster, a GKE cluster with the network policy add-on so that network policies can come into effect. You can also get into the API reference and see on what all can be done using the network policy object.
Pod presets are also objects in Kubernetes. So in order to see if there is any pod preset configured already, let's give the kubectl command get pod presets. So we may not be able to see anything because pod presets are not enabled by default. So in order to enable pod presets, we need to have this API version settings.k8s.io/v1alpha1 enabled in the runtime config. So I'm just copying it from there. Yeah. So now let's get into the file in which we need to add this nano etc Kubernetes manifest kube API server.yaml. Okay, so here you have this kube API server command, and after this command you need to put the runtime config. So 2 hyphens runtime config is equal to settings.k8s.io, whatever we copy from there, and then we need to say it's true. In addition to this, we also need to enable the admission plugin. So here we just need to add pod preset. So Ctrl X Y to save this. And now let's try to see if there is any change in the output for the same command. We're now trying to see if there is any pod preset, but this time you see no resources. You did not get any error. So that says there's no resources found. Now let's go ahead and create a new pod preset. So I'm just naming this file as podpreset-example.yaml, and inside this I'm going to give 3 hyphens and 3 dots to end and begin with, and these are optional. I'm going to give the API version, which is nothing but the settings string, whichever we copied just now. So this is what we need to give here, and the kind is nothing but pod preset, and after that we give a metadata just like we give it for any other object, and we give it a name, give it something like pod preset example, and after that we need to give the spec of it. So under the spec we would specify something like labels, the selector, just like we give it for a deployment or a replica set object. We have to pick pods based on labels. So we say selector, and under selector we say match labels. We can give it any labels. So to keep it simple, I'm gonna give something like label key, like label value, a label key and label value. So this is just a name. You can give anything here. So the selector part is over, and after that you can add some information. Here is the place that you specify what information that you want to add to the pod. So it can be anything that you would normally add to a pod. It can be an environment variable, or it can be anything like that. So in this case we would give certain environment variables which could be injected into the pod or its container. we can have two variables. Let's start with the first one. We can have it as country is the key of the variable or the variable name itself, and the value can be India. So the next variable we can have continent. We can give it a value Asia. So we have given two key value pairs, which is nothing but the environment variables, and our motto for this session is to inject these environment variables into the pod. And the label selector is the key thing using which the pod preset would pick a pod. Okay, so the pod preset configuration is ready. Control XY. Let's try to create this and see if there's any error of it, or if it gets created successfully. So create -F. Okay, I think it got created now. So let me see if this is showing up. Yeah, it's showing up there. Now let's create a pod which could get information from this pod preset. The key thing to note here is the label selector. So nano pod example.yaml, just a name. You can give anything you want. So as usual, 3 hyphens, 3 dots, which are optional. We start with the API version, so which is nothing but v1 for pod, and the kind is going to be big P OD pod. And then the metadata for the pod, we can give it some name. So let's give pod -example, and after that let's give it some labels. We have to give the same label that the pod we specified as the selector in the pod preset section. Label key and label value. Yeah. So now let's get into the spec section. Inside the spec we can say what containers we want. Let's give one container with the name ctr -example, and let's give it an image httpd, which is Apache image, which is a web server. Okay, so now let's try to create this pod. The pod is created. Let's see the status of the pod. The container is getting created. You can also use the --watch flag just to see the status getting changed. Instead of giving get pods again and again, you could also give the --watch flag, and you see the status getting changed. Now you know that it is running. Okay, now let's try to get into the container inside the pod. So kubectl exec -it pod -example, which is nothing but the name of the pod, but it is not YAML because that's a file and this is the object. So just give pod -example, and then you can give bash to get into the bash prompt. We are into the bash prompt of it. Let's try to print environment variables in this container. So we have got a bunch. We gave something like country India and the continent Asia. So let's try to grep them alone. So grep continent. So we got Asia, what we gave in the pod preset. We did not give it directly inside the pod. This is because the information from the pod preset was injected into the pod because the labels matched. And now let's try to give country. You would get India. The other way of printing these environment variables is like this. You could use the echo command and you put the $symbol there before the variable name, and then you give something like continent. You would get it. Similarly, if you give country the same way, you should be getting India. So in this session we saw how pod presets are getting created, what we need to enable in the API server file, and how to inject the information from the pod preset to the pod based on label selection. And we got into the container of the pod and we saw those environment variables, what we gave inside the pod preset, getting injected into the pod. Hope this video was useful. And we thank you for watching this video and have a good day. Bye.